Hey guys, now that you are comfortable telling me whether two triangles are similar or not, we're going to actually use similar triangles to set up and solve proportions. So let's take a look at number one. Picture's a little hard to see, but hopefully you can see the two triangles that are drawn there. And we've got XZY, so that's the pink one, and then we've got ZUV, so the green one there. So we need to look and first decide how we know that those triangles are similar to each other. So first thing you should notice is that we have some vertical angles there. So this angle right here has to be congruent to that one. And then let's check the sides and see if they're proportional because we're not given any other angles, right? So take a look at YZ over UZ and XZ over VZ. So when we're looking at these, YZ is right here, so that's the 25. And that's going to be proportional, or we're checking to see if it's proportional to this 10, UZ right here. Both of those lengths are the shorter ones on the sides there, right? And then let's look at XZ, which is 35, over VZ, which is 14. And we can check both of those out. They both simplify down to be 5 over 2, which means, awesome, these triangles are similar to each other by side angle side similarity. Hopefully you guys are pros at that by now after doing that card sort. So side angle side similarity. We have to write our similarity statement. So the triangles are going to have to be in the right order. So let's say I wanted to start at X and go to Z to Y. So XZY is going to have to be similar to, I went towards my vertical angle, right? So I'm going to have to start at V and go to Z and U. So triangles are similar by side angle side similarity. Now we're going to use that to solve for this other missing side, XY. All right? So what I would do is keep the same proportion, right? YZ over UZ, because we already know that one. And we're going to say now that that's equal to YX over UV. And you can get that either by looking back at your triangle again, or once we wrote the similarity statement, you can check the order there. If we've got YZ to UZ, that's the same as YX to UV, so we can do it there. And let's plug in what we know. 25 over 10. XY is what we're looking for, right? So you can either put XY or you could just put an X because that's what we're solving for, right? And then UV is 16. And we're just going to cross multiply, same as we've been doing to solve all of our other proportions. And we get 10x is equal to 400. Divide over that 10, obviously. And we'll get down to x equals 40. Which means this length up here, xy, we can go up there and set it as 40. Cool? So first you have to show me that the triangles are in fact similar and give me the similarity statement, and then you have to set up a proportion and solve it. Not bad, right? Let's look at these two. Here we've got some overlapping triangles, so the first thing I'm going to do is actually draw them separately. So I've got one triangle here, RSV, so RS is 10, there's an angle drawn in there, and SV is 8. And then I have another triangle over here. This one is R, T, and U. Again, I've got an angle drawn in there. I've got this is 12. RT is what I'm eventually going to be looking for, right? So I'm going to put an X there because I don't know what it is. So I have to try and figure out if these angles are actually similar or not, right? Hopefully you guys can see from the original picture that angle R is a part of both of them because they are overlapping, which means right away these triangles are similar by angle-angle similarity. Overlapping triangles are the easiest ones to write the similarity statement for, because you just start at the angle that they share and go to an angle that's already congruent. So RSV for the little one, similar to RTU for the big one. Cool. And let's set up our proportion. So R to S, which is 10, we know is going to have to be proportional to RT. That's what we're looking for. And then SV over TU. And again, you can get your proportions from your triangle if you're comfortable with that, or you can get it from your similarity statement once you've got them in the right order. So RS is 10, RT is X, because that's what we're looking for. SV is 8, and then TU is 12. And again, just cross multiply. You guys should be pros at this now. So we get 8x is equal to 120. Divide both sides by 8, and we get x equals 15. So since that's the whole thing that we were looking for, we can just put the 15. Now be careful, because sometimes I might ask you just for ST. So you might have to do all that work to then go, okay, well, if 15 is the whole thing, ST is then going to be 5. So be careful of what we're asking for in these questions. Cool? All right, 2 more. Bear with me. All right, this is going to be a shorter video. Let's zoom in a little bit, because this picture is a little bit smaller. All right, so looking at number 3, we got a couple of things going on there, right? First of all, you should see that bow tie shape and know that that means we have vertical angles. All right, and then we've also got some parallel lines going on. So I'm going to draw the parallel lines with some yellow so we can see them. You can pick either one of those lines as the transversal. It doesn't matter. If we pick CE as the transversal, it's going to get me angle C and angle E to be congruent. Or if we pick AD as my transversal, it's going to get angle A and angle D to be congruent. Doesn't really matter. Whichever one you happen to see first is fine. Either way, we get angle-angle similarity. And we're going to have to write those triangles. So let's say I wanted to do ABC first. So I started at the one with 2 tick marks on the arc and went to the vertical angle. So I have to go the same order over here. So similar to triangle DBE. And we're good from there. Now we have to set up our proportion. We're looking for BE. So I'm going to put an X on BE so that I remember that's what I'm looking for, and so I remember to include it in my proportion. So I'm actually going to start with BE. BE is going to be proportional to BC. And let's see what other sides we were given. I'm looking for BE. I was given BD. So BD's got to go up here, and BD is going to be over BA. All right, let's plug in what we know. BE is what we're looking for. BC is 54. BD is also 54. And then BA is 36. Cool. Let's cross multiply. If you guys don't need to draw those circles, that's totally fine. You guys should be comfortable with cross multiplying. But just in case, I'm writing them out for you. So 36x is equal to 2,916. Divide both sides by 36. And we get our x value to be 81. Which means BE is 81. Cool? Hopefully you guys are following along. These should not be too bad. Alright? One more to look at. This one gives you more of a real world example, but we're still just going to pick out these triangles that we see and hopefully be able to show why they're similar and then solve for BF. So I'm going to draw the little triangle up here first. We have BFG. And we're given FG is 6.5. And then we have a bigger triangle, which is BAC. We're given this is 24. Now we have to look, whoops, you guys can't see, sorry. We have to look pretty closely at this picture it is a little hard to see some of it, but this length right here, AF, is 17, but that's not the whole thing. That's not AB. BF is what we're looking for, so I'm going to put an X there, which means I have an X right here. And that means then that BA is this X and 17 together. It means that it's X plus 17. We have to add those two together. So if we knew what X was, we could just add them together and get a value, but we don't know what it is. So it's going to be X plus 17. Now we have to know if these are even similar or not. So the thing that I forgot to mark on there is that these lines are parallel to each other, which means these angles are going to be congruent because they're corresponding. And these ones would be congruent because they're corresponding. Or if you saw it, angle B is being shared in both of them. So we could use reflexive property there too. Either way, you get at least two of the angles to be congruent. We got all three in this case. But our reasoning then for this triangles being similar would be angle-angle similarity. And we've got to write our similarity statement. So again, I think writing the overlapping ones is probably the easiest. So triangle BFG similar to triangle BAC. Cool. Double check me. BFG, BAC. We should be good. All right, we got to write a proportion now. Look at these two triangles. X over X plus 17 is going to have to equal 6.5 over 24. I skipped the step of actually writing the sides proportional. I guess I should have done that, my bad. BF over BA and FG over AC. My bad, guys. But hopefully you could have figured that out on your own, right? Then we got to cross multiply. So 24x is going to equal 6.5 times x plus 17. I'm going to move down so you guys can see what I'm doing here. We have to distribute that 6.5, so 6.5x plus 110.5. Subtract that 6.5 over. You guys know this algebra, so hopefully you're okay with me not completely showing all my work. We should get down to x equals 6.3 feet, because those are the units we were in before, right? So 6.3 feet doesn't really make sense, so I usually take that 0.3 and multiply it by 12. So it's 6 feet, 3.6 inches. Either one of those answers would be okay with me. Cool? So it's set up the triangles, make sure that they're actually similar to each other, and tell me why, and then set up a proportion and solve for the missing side length. It's not that bad. We're going to do a ton of practice in class tomorrow. If you have questions, make sure you wrote them down, and I will see you guys tomorrow. Bye.